Interest rates come in two flavors. The actual interest rate we earn and the named interest rate. Nominal means named. So in one sense, when we start this process, we have a named rate. Say I'm telling you you're going to make 9%. Well, is that 9% per year? Is that 9% per month? Is that 9% a year but compounded per month? So the nominal rate doesn't include the compounding frequency. The effective rate gives me whatever my nominal rate is converted to a once a year piece. But let's think about this like a credit card. Suppose my credit card names a rate of 24% a year. Compounded monthly. What are we actually earning? Wait a minute. 24% a year compounded monthly should be 2% a month, right? I think 24 over 12, right? So if that's the named rate, what's my effective annual rate? What's this really earning? Or wait a minute, how am I going to figure this out? How do I get an effective rate? Let's do it the easy way. Let's figure out the future value of an investment of one. Using this interest rate of 2% a month. The future value of one. Doing compound interest, what's the future value compound formula?
Um, one goes way to the, well,
Exactly. I have an interest rate of 2% period of 0.24 over 12. I'm going to go for 1 year's worth of periods. That's 12 periods, 1 year. So I get 1.02 to the 12th. Grab your devices, tell me what we get.
1.272.
Which means if I subtract 1, that's giving me the interest rate because I took 1. At the end of the year, I have 1 point something, right? That's the increase I earned due to interest. So my effective interest rate, my effective annual interest rate is really 26.82%. In spite of me saying it was 24%, it's really something higher. Because compounding frequency matters. Adam, you're looking at the board like it, you don't like it. Talk to me. Okay? All right, all right. Just reading your face.
You multiply 12 by the next, isn't it?
I multiplied 12 by the number of years I was doing it. So I said 1 year's worth, so I did 12 1 year, 12 periods, right? So in general, I'm going to take this 1 plus I to the n, and I'm going to think about it in terms of periods rather than time frame. So if I have m per year, then I took the rate per year, divided it by that, so that I r over m. And then my time, n, is really number of periods. So it's number per year times number of years. And on page 25, we actually see a definition for the nominal interest rate being exactly that, the quoted rate divided by m. So that key phrase that we used here, compounded monthly. Sometimes it's converted monthly. Sometimes it's charged monthly. Sometimes it's accrued monthly. Sometimes it's given in the frequency. Compounded 12 times a year, compounded monthly. So we'll see that in a bunch of different phrases in whatever lending agreement we actually sign. But the purpose is that key phrase, monthly, somewhere in this problem. The Federal Truth in Lending Act requires the lender to give you this number. Until recently, it didn't require it to give it to you in any big font. If you watch an advertisement for a car on TV, I know the last time you saw a commercial was a long time ago, but if you watch a car commercial, as they're talking about this is how much the car costs, there'll be this flash of white text across the bottom of the screen, teeny weeny little font. If you freeze that frame, you'll actually see they give you the annual interest rate. It's required by law now that you get this number, but they'll put it in tiny, tiny print.
Why do they get to say that it's 24 a year when it's 26? But like,
It's 24% compounded monthly, because that's equivalent to 26.82%, right? So I have to say that this is really 26.82% somewhere. I just don't have to say it loud and proud. I can say it as tiny font. As a matter of fact, I remember an ad for trucks. And there was this big picture of the truck on top of a mountain, and the mountain was full of white text. And hidden in there was the fact that the actual APR on the loan was 31.5%. Keep talking to me.
if you compound something daily, is it gonna be even bigger? Like,
Yeah.
the periods being like more frequent, make the interest bigger.
For the same rate, yes.
Yes.
If I took this 24% and said, let's compound weekly,
Yeah.
we could do that right here. If I did 24% compounded weekly, well, then my per week rate is 24 over 52, which is not a pleasant decimal. 24 over 52 is this disgusting looking thing, right? But that's per week. So that's 0.4615 percent per week. But then what's the equivalent annual rate? it'll be 1 plus 0.24 over 52 to the 52. And then I'll subtract 1 off to get the actual percentage, right? I'll take away the principal and only look at the rate. So let's do that. There's the 1 plus, oh, wait a minute, 0.24 divided by 52. Add 1, raise it to the 52, subtract the 1 off. It's actually 27% if I do it weekly. And if I do it daily, 0.24 over 365, add 1, raise it to the 365th. 27.1%. I don't know how many of you remember. There used to be a large number of "we'll give you credit even if no one else will" advertisements or payday loans from, they were primarily Native American banks. And the reason they were Native American banks is because the bank operated in Native American territory. It wasn't subject to the same FDA regulations as the rest of the, FDIC regulations as the rest of the country. Because technically Native American banks operate out of a different country. They were charging lending rates equivalent to several thousand% a year. 10% a day. What happens? I mean, look, this was at 0.06% a day, and it worked out to 27%. If I'm at 1% a day, 1.01 raised to the 365th, that's 38%. 1% a day is 38%. That's ridiculous. There was a whole new set of regulations created to do this. You'll often see this per whatever rate referred to as the periodic rate, because it's per period, right? Almost every credit card in the country converts their annual percentage rate to an equivalent daily rate. And then use that because there are different numbers of days in a month, right? So it makes more sense for me to go by the day than one fixed per month if I'm actually charging you interest based on the number of days. When you get a credit card bill, it will tell you this many days were in this period, and the daily periodic rate, they've divided their annual rate by 365. But then they have to work back to the actual APR, which better appears somewhere on your credit card statement. Most recent changes to the credit card, I believe it's Sarbanes-Oxley, require that the APR be in a minimum of a 14-point font and must be bold-faced. So they can't get away with hiding it anymore. But what this means is it's actually most useful to you to do comparisons based on equivalent rates on APR rather than on nominal rates. Here's an example, top of page 27. Let's just read it through. We don't even have to do the math. Annual rate of 15.25%, interest compounded semi-annually. Bank B, interest at 15%, compounded monthly. Where do you want to put your money? Do you want to go with 15.25% compounded every 6 months? Or do you want to go with 15% compounded every month? Well, let's find out. Bank A, 15.25%, right? So that's 0.1525 divided by 2 because it's only done twice a year. So I take 1.07625 and square it. And then I subtract 1. The rate is annually 15.8%. What about the other bank? 0.15 divided by 12 is 0.0125, so 1.0125 raised to the 12th minus 1. That's bank A up there. This is bank B. I get almost 0.2% more out of bank B, even though it's got a lower nominal rate. Compounding frequency makes a big difference. So I'm required by law to give you an equivalent annual rate, but it isn't always easy to find until the Truth in Lending Act came around. Here you go. A review of online payday loan websites in 2017. A $30 fee for a 1-week loan of $100. So a week's loan, 7 days at 30% a week. That's an annual rate of 1,564.3%. But it's compounded every week. $1.3 raised to the, how many weeks in a year? 365 divided by 7. Oh, minus 1. Your interest rate is 873. Wait. I got to put 2 more zeros on that to do an interest rate. 87 million%. Payday loans suck. By the way, if I instead of doing a 7-day loan, I do they called it a 2-week, but it was really 18-day loan. The fee stayed the same. That means that rate is only 20,000%. Remember, I have to multiply by 100 to get it into percentages. The highest loan APR permitted by the Truth in Lending Act for payday loans has been lowered to, I think, 550 APR, so 550%, which gives you an effective APR at a weekly loan of about 64,000%. Don't take a payday loan, that ain't worth it. If I have a nominal rate of I, whatever it is, then we will write I with a superscript M in parentheses. Those parentheses are important because this is not an exponent. This is just a notational quirk. And that means I want to compound that interest rate at M times a year, which means my per period rate is I divided by M. So in the calculation we just did, we had 2 different periodic rates. We had a nominal rate of 15.25%, but it was compounded semi-annual, which means we would write I2 equals 0.1525, and then we used half of this number in our actual calculation. And in the other one, we had an interest rate of 15%, but we were compounding 12 times a year because it said monthly. And we used that 0.0125 for my actual rate. Well, then I can do exactly the calculation we just did. The equivalent annual rate actually, this should have that superscript M on it, over M to the M. So I can figure out I, the effective annual rate, by converting this from a periodic rate to an annual rate. On our Canvas page, there should be in a section titled In-Class Examples, an Excel sheet for Chapter 1, Section 10. Let me pull up the Excel page. Did he? There we are. Chapter 1, Example 10, Nominal Annual Rate. I'll pull it up on here, so you don't have to pull it up right now, but 217, wrong class. Examples. So here's what I've done. I've got a nominal rate of 12% here. And I did each of these calculations based on going both ways. Hey, let's take that and figure out the per period rate by taking 1 plus 12.12 and raise it to the 1 over m. So instead of doing it once a year, I say, oh, take the square root to get back to half a year or a quarter of a year. Notice these numbers are getting smaller and smaller and smaller, right? But I've got quarterly, monthly, weekly, daily. These numbers get tiny. These are the per period. That's my periodic rate column. But over here, I'm actually saying, well, let's do this calculation the other way. Notice what happens, though. These approach a particular number. My nominal rate goes down. Compounding more makes the effective yield go up. Wait a minute. Can you see the formula that's up there? Top of that sheet? What's that formula say up there?
Well,
What the hell is an LN here? All right, wait a minute. Let me look at this formula again. Let me look at this formula again. I want to rearrange this. Solve for IN. Here's a way I can get the nominal rate separated from the actual equivalent rate. What happens as I compound more and more often? Well, then I need to do calculus. Yay, calculus. I like calculus. I need to take the limit as m goes off to infinity. Here. M appears in two places. Shit. When I take an mth root, this number gets closer and closer to 1 as m goes to infinity. So the thing inside this square bracket is going to get closer and closer to 0. But the thing outside the square bracket is going to go off to infinity. I have infinity times 0. This is an indeterminate form. And when we learned indeterminate forms, we did one of my favorite people. There's a rule about indeterminate forms. Who's it named after? Not one, Jack or Phil. Most of our indeterminate forms were not infinity times 0. They were like 0 over 0 or infinity over infinity. Whose rule did we use? L'Hopital. So I need to rewrite this to make it L'Hopital's rule. And what I can do is I can take the limit as m goes to infinity of 1 plus I to the 1 over m minus 1. That's going to 0 over 1 over m. That's also going to 0. Which means I can use L'Hopital's rule. With a bit of remembering how to do derivatives from calculus, my brain says, how do I take the derivative of 1 plus I to the 1 over m? This part right here is what I need to take the derivative of. That's an exponential, but its base isn't e. The derivative of e to the x is, so I need to take into account the base, and that means I get an ln of the base. It means I'm going to get an ln of 1 plus I. Oh, okay. But that's not just an x up there, in this case an m. So I do the chain rule. And the chain rule tells me derivative of 1 over m. What's the derivative of 1 over x? Y'all took calculus. I know you know this one. It's x to the minus 1. What's the derivative of x to the minus 1? Power rule. That's going to change to a minus 2. What do I do with that number as well? Wait a minute. I have a 1 over m down here, so that derivative is minus 1m to the minus 2, which means this cancels with that completely. Yay! What happens as m goes off to infinity? As I take the mth root over and over and over, I get a number that gets closer and closer to 1, which means as m goes to infinity, this piece goes to 1. And that means I get ln of 1 plus I. because that doesn't depend on M. That's a constant. And that's the reason that we used an ln in that formula. Now, the other side of this, if I work backwards, that's the nominal rate, right? This is Im. We could even write it as I infinity, like that. But what does it mean to compound infinitely often? We never ever stop, right? As soon as you give me the money, I start giving you interest. Every microsecond for the rest of time until you take the money back. The rate's going to be teeny tiny. How do I figure out the future value? Well, I need to work the other side of this, which means I need I instead of I infinity. Okay, well, that means that I end up with getting rid of this ln, and I get 1 plus I is an exponential. We've seen this before. It was a long time ago, but this was actually an example. In Calc 1, the future value continuous compound. We'll do more about this on Thursday, but I want to get through something else before we get to it. But this is something we will use most of the time as a theoretical upper limit, because really very few banks actually do this. But if we're going to establish some sort of maximal or upper limit to what we are doing, we're going to use this as that theoretical upper limit calculation. The best you can do if you're earning 5% is to have that 5% nominally compounded all the time. We'd use this for. Questions? A lot of this is just to standardize the notation we're going to use. If you look at the ACTEC formula sheet that I put on our Kansas page, you'll see that I with the superscript M and the I infinity both in there.
Why the Excel values go down as we compound more? When we looked at the example, they were compounded more, they decrease.
Well, but notice what this is. This is our nominal rate, right? Our nominal rate was 12%. Then I'm showing, hey, the yield gets closer and closer to a fixed number. That's all I was showing with this, was, hey, look at what's actually happening to our yield calculation. It's changing. Gross behavior, we could change this. 1 plus I over M to the M, right? That's my total future value. So we'll use that number, we'll divide it by that number, and we'll raise it to that number. I'm going to earn 12% here. I'm going to earn more there. More.
So what is it?
This number, this was our actual per period rate. So the per period rate went down slightly, right? That's the IM calculation according to the textbook. Unless I screwed something up, that's the IM. Now notice what's going to happen here is I'm going to get e to the 0.12. Why did that give me a calculation error? Oh, because I forgot the parentheses. Which is almost the same as what we're getting when we compound daily, isn't it? So daily versus continuously is a very, very, very small difference. Make sense? This is our actual future value.
That was, I get it. Yeah.
Well, again, I stole this formula direct from the textbook, right? Thing, this formula. Unless I did something dumb in the calculations, which is possible. 1 plus I to the 1/2 minus 1 times 2. Okay, so if you want to earn 12%, if you want to earn 12%, you should tell me that you're going to charge me 11.66% compounded semi-annual. That's why this one's going down, because you have to charge a little less to make your yield 12%.
Okay.
So this is the rate in the middle column, is the rate you want to charge me to get 12%.
Thank you.
You're welcome. No, I want it. That's why there are two different columns there. Whew. Like, I know I did this for a reason, because I actually have to charge you a little less to make it come out to be 12% if I'm compounding it. It goes down. If I can't explain it, then I didn't write it down right. So let me make sure I can explain it. Otherwise, I fucked up. Okay. All of the interest calculations we've done so far. Interest gets paid at the end of the whatever. End of the year, month, quarter, 6-month period. Interest is paid on the money you left me for the previous period. This is referred to as interest paid in arrears. I'm paying you for the money you've already given me. This is often required by law. But that phrase often means that sometimes I get away without doing it this way. We can do this by paying interest in effect up front. Since this is paid at the end, what if I paid or applied my interest at the beginning? Well, then this is interest paid in advance or interest payable in advance. But if I'm paying you interest so that you loan me money, and the interest, well, wait a minute, I'm paying you interest. You gave me your money. I'm going to give you more at the end. Or you borrowed money from me and you're going to give me more at the end. That's what interest is. This is going to change the way I do my rates. So let me think about this. $1,000 at 10% per period. I don't care what the period is. For one period, just one period. So what's the interest? What's the interest you're going to earn over that period? Of $1,000 is, how much is it? Cash. What's 10% of 1,000? Okay. But I want to apply this in advance of you giving me the money or me giving you the money. I want to apply this up front. So instead of me saying, you're borrowing $1,000, here's $1,000. I'm going to say, you're borrowing $1,000, the interest is $100. Here's 900. I'll take the interest off up front. You still only owe me $1,000. One period from now, whether that is a week, a month, a year, or 5 years, one period from now, you owe me $1,000. I will have earned 10%. I will have made $100. But this is not the same as an effective annual interest rate. Because what this really means is that I took that $100 off in advance. What's the actual interest rate here? Let's treat this like I'm trying to find the effective annual rate. It's only one period, right? So future value is P 1 plus I to the 1. And it's I over 1 because it was only one period. So that's 1,000 is 900, 1 plus I. 1 plus I is 10/9. So I subtract 1 is 1/9. Give me a decimal. Matter of fact, it keeps repeating, right? So in spite of the fact that I said we were going to charge you 10%, effectively I charged you 11% by taking the interest in advance. So a lot of people were unhappy calling this the same thing as interest. So we're going to give it a different name. We call this a discount rate. And if you think about it, that makes a little more sense to me in terms of the everyday shopping I'm used to doing. I got a discount of 10%. So $1,000 cost me 900. For any accumulation function. A of T. The annual effective discount rate. D is A of 1 minus A of 0 over A of 1.
So isn't annual effective rate just future value? Is that the same? Or an interest rate?
For an interest rate, that's measuring the future value of a number of 1, right? But what's this doing? It's not measuring it against the present value to the future value. This is measuring against the present value the future value brought back. So it's this denominator that makes a difference. In interest rates, it's A of 1 minus A of 0 over A of 0. It's an additive behavior. We're looking forward for interest. But in discount, we're looking back. So we're dividing by A of 1.
Discount rate more profitable than interest.
Yes, but again, the law says I'm required to give you the effective annual interest rate because everybody wants to think in interest. But in paper, I can write it different ways. It was actually the very next line of my notes says, hey, wait a minute, the only difference between this and interest is what the denominator is. Interest compares to the beginning when we start. Discount compares to the end. Interest through the discount is regarded as being paid at the time the loan is made, not when it's paid back. So if I think about borrowing money to go buy a car, right? Would it make sense for you to tell me, I need to borrow $20,000 to buy this car. I'm going to pay it off over a couple of years. So give me $16,000. I need $20,000 to buy the car, don't I? You need to give me $20,000 now, and then we'll figure out what I need in the future. That's interest style. But discount, this sounds like those treasury bonds, right? I'm going to give you $100, the Canadian treasury bonds we were talking about last week. But you only have to pay me $98.30 today. I'll give you $100, but you only have to pay me $98.30. I've discounted rather than work forward. Discount rates are only used in the United States in specific government transactions and investments. You won't see them everywhere. You'll see them in very small places, but the bond market works in discount. They give effective interest rates because it's required by law, but they work in discount. Okay, wait a minute. A of 1 minus A of 0 over A of 1 is our discount rate. Rearrange this formula. A of 1 minus A of 0 equals A of 1 times D. So if I switch those two sides, A of 1 minus A of 1D equals A of 0. Or A of 0 is A of 1 times 1 minus D. Oop, went off the bottom of the screen. You can't see that. So this 1 minus D thing here is acting like our present value behavior. So let me think about it. Present value for interest rates. What did we call the present value factor for the interest rate calculation? This was Thursday. We wrote it two different ways, and I said that there's actually a formal letter for it, but I tend to use it the shorthand way. There was a name for present value factor.
You said present value factor or discount factor.
I'm sorry?
You said present value factor or discount factor.
Well, now I'm talking about the present value factor as opposed to the discount factor. So you'll notice with this formula right here, I give you the future value A of 1. You tell me the present value A of 0. My future value is $1,000. My discount rate was 10%. That makes this thing inside parentheses 0.9. My present value is $900. But when I was doing interest, we gave that a different name. Say again, V. And we also said that V could be written in terms of an interest rate. What was the formula for V in terms of an interest rate?
Whatever one was,
Awesome. So if I want to know the interest rate that's equivalent to a discount rate, I should set those equal to each other. And I should say, oh, well, let's make this 1 over 1 plus I equal to 1 minus D. We can solve for one in terms of the other, right? So I hope it's easy to write D, switch sides. D is 1 minus 1 over 1 plus I, which gives me, now let's simplify that. Common denominator will give me 1 plus I over 1 plus I minus 1 over 1 plus I. The ones will cancel. I over 1 plus I. If I know the interest rate, I can give you the discount rate. We can rearrange and finish this the other way, and we can write I, 1 plus I times D equals I. I want to get I all alone this time. So D plus ID equals I. Move the I to the other side, and I get D with I minus ID. Factor that out, I get I times 1 minus D. So I is D over 1 minus D. If you know the discount rate, you can figure out the interest rate. Let's check. If you put in 0.1 to this equation, what do you get? The discount rate of 10%. You get 0.11111. 10 over 9, 11.11%. Perfect. That worked. So if I tell you the discount rate is 10%, somewhere in the paperwork, it better say the APR, the annual percentage rate effective, is 11.4. Questions? If I can compound interest, I can compound discount the same way. Or I can look at the periodic rate, right? And I can say, oh, I want to do this with a discount of 10% compounded quarterly. Wait a minute. If my discount is 10% compounded quarterly, oh, I'm going to have to divide by 4. And then I need an effective annual discount rate, right? I can have a periodic discount rate as opposed to an annual discount rate. Okay, here we go. Ready? Where's the bond things? Oh, I put that mark on my Canvas page. Let me go to the other one. Tap. Web page. Treasury Direct. That's the one I want, not the Treasury page itself. Here's where you can buy bonds from the US government. These are given as APR, but bonds are actually sold at discount. Page 33. Here is the sort of thing I will see if I actually go to the Treasury website that we were just on and look at a Treasury bill like this. There's my discount rate right there in that column. We've pulled out a couple other columns. We've pulled out an ID column. We've pulled out, the web link is right there, but that's Treasury Direct. That's the website we were just on. Now, something that messes with me all the damn time is in order to make their calculations easier, the government assumes a 360-day year, 12 months at 360 at 30 days each, period. Every month is the same length, and every month is 4 weeks. Despite the fact we just said it was 30 days, in some cases they're going to count it as 28. No, they're going to count it 4 weeks. But they will use actual dates in here. The calculation I did is this one. So let's look at that row. A 26-week long bond issued April 20th of 2017, maturing October 19th, 2017, at a discount rate of 0.945%. So why is that investment rate 0.963? That's the information I really need, right? So I'm going to work out my discount rate. Simple discount pricing. Forgot the A. Present value is accumulated value times 1 minus discount rate times time. This looks exactly like the simple interest formula, but it was 1 plus RT, right? Because interest rate is paid forward, discount rate is taken back. That's why present value and accumulated value are on the other side from each other compared to the interest behavior. So, according to the book, if I am doing this 26-week idea, let's call it a $100 bond. How much do I pay for this $100 bond today? Discount rate. Discount rate is 0.00945 because I converted from percent to decimal. But then I need the time. 26 weeks, 26 times 7 days out of a 360-day year. I want you to give me this number to 6 decimal places. Multiplied 0.00945 times 26 times 7. Divide the whole thing by 360. To 6 decimal places, I'd put a 0 on the end of that, right? Ready for the sneaky part? $99.522250. Price per 100 is given on the treasury page. So if you want to buy $100, you want to buy $100,000. You just take that and multiply by the number of hundreds you want to buy. You want to buy some fractions of hundreds? Fine, same thing. Just multiply by how much you want to pay for. What's the interest rate? I need the same time behavior, right? I could use the discount per period, but this is not the same because it's in 26 weeks. Here's the part that bothers me about the government. This was calculated with a 360-day year. Interest is calculated with a 365-day year. Why are you with me like this? Because of the government we can't. I'm going to cheat. And rather than use some crazy looking formula, I'm going to use the easiest formula for interest, the one we started the game with. Interest is principal times rate times time. So this number was 99.522250. That's how much I put in. That's my present value. How much interest did I earn? I didn't earn a whole hell of a lot in 26 weeks, but how much interest did I earn? I put in 99.52 to the, I got out. How much did I get out? How much did I get out? So the difference is the interest I earned, right? Less than 48 cents. But I have my interest, I have my principal, I have the time, 26 weeks, right? So I can say 0.477750 equals 99.522250 times this unknown interest rate times 26 weeks. Notice that's a 365-day year. So I just divide to solve for the interest rate. R is 0.47775 over 0.9952. The point goes here, not there. 9952225 times 26 times 7 over 365. What do you get when you do this calculation? Give me one more decimal place, you would call it a 3, right? So that's 0.963%. Again, I will point out to you, take a look at the table. There's our investment rate, the interest rate that's equivalent to this discount for the period of time we chose. By the way, this method is different than the one the book uses on page 34. They use the 1 plus I to the n routine, which works out to give me the same thing. You should check the other 3 rows, row 1, row 3, row 4. Make sure you get the same price per 100 and the same equivalent interest rate. It's important to be able to swap between these two. If you go online again to that website today, you can check the rates right now. We can look at historical rates. Notice 10-year versus 30-year, different times, all sorts of things. You can make these purchases online today. You must have an electronic account to be able to do this right now. You don't get physical paper safety bonds, safety, security certificates. That's the word I wanted. You don't get physical bond certificates. You used to be able, when a baby was born, you give them a savings bond, would be mature in a certain number of years. Hey, this is for you when you grow up. They sold 18-year bonds on purpose. Birthday to 18. Here you go. And they sold them in increments of anything from $50 to $500 at that time. And you got a physical piece of paper to give to the parents. But the account was opened for in the child's name. Therefore, you need the child to have a social security number. Highs in the 80s for those rates were around 15, 16%. In 2008, those rates hit 0. Why? Because we went through this giant financial crisis in 2008. And now they're back to 4-ish%. So we're getting different behaviors. There's a lovely graph available at the Federal Reserve again in our web links. Federal Reserve Economic Data, this website, FRED, is run out of the St. Louis Federal Reserve. And if you go to the St. Louis Federal Reserve, you can chart interests, things over time. Huge amounts of information are available here. You want to spend some time looking at the way money has been changing over years? This is the Consumer Price Index, which is what we use to judge inflation rates. Over the last 75 years. And you see marked in gray are recession areas. There's all sorts of information on this, and that's why this link is available to us, so we can get at a bunch of the data that is useful to understand where these calculations are coming from. Again, I'm going to say we have a nominal discount rate. So if we do DM, we're really doing that number divided by M. So that's per period rate. And then we can go back and say, oh, well, then we have an effective annual rate. But effective annual discount rate is rare. That looks just like our interest rate effective behavior, but we don't do this a lot. You'll see some of the problems in the text are rigged to use this, so you can familiarize yourself with it, but in practice, this doesn't show up very much, even when using notes and things that are traded by discount as opposed to by interest. Yes, ma'am.
When can we use the discount to like getting the discount from the interest rate for investment, just like D equals
I plus
Yeah,
1 over I. We'll use that when we're given them in the same period.
okay, so we updated the discount rate, within a year of 365, then we could use that to calculate interest again.
But the problem is that those stupid use a 360-day for discount and a 365-day for interest, and it makes me crazy. So what we often have to do is work with those interchangeable periods. You'll find on our calculators in that finance menu, one of the things that shows up, it's under apps, finance, is this thing down here labeled DBD, days between dates. If you actually need to know the number of days from this day to this day, I use this. Now, again, our calculator manual for the finance section is on our Canvas page so that you can actually look up what the format is to enter day, month, year, month, day, year. I don't remember which format of date it uses. But it's a lot easier than going 2016 was a leap year, but 2020 was, again, takes it all. And that way I know whether I'm doing a 360-day or a 365-day year, I know the actual number of days used. It's going to make us a little weird for a little while. One of the problems is that I don't think it always makes sense to swap back and forth. So I like using a 365-day year much more often. But this is the federal government. I can't tell them what to do. Questions? Okay, I am hoping that I will finish this chapter on Thursday. And if you look carefully, that makes our homework due the following Thursday and the exam the Tuesday after. So it's coming closer, 2 weeks from today. So you should be doing some of these and asking me questions. We got through the end of section 5 now, and we'll start section 6 and finish section 6 and 7 on Thursday. I will see you all then. Have a wonderful rest of your day.